This is part 2 of the Titanic notebook. In this section, I'll be talking about exploring and understanding the data. So here's the columns in our data set. We have the survival. So 1 if they survived, 0 if they did not survive. We have the class. So 1 refers to first class, 2 second class, 3 third class. We have the name of the passenger, their sex, their age, the number of siblings plus the number of spouses on board, number of parents plus children on board, the ticket number, and a variety of other information about the passenger. Some quick notes here. If the person is less than 1 year old, you will have a fraction. And if the age was estimated, it'll be in some form where there's a 0.5. So as I mentioned earlier, there is the SIB, SP, and parts. That one is a bit unusual. And what this means is we are summing together, for SIB, SP, we're summing together the number of siblings and then the number of spouses on board the ship. So if, for example, here, if there was a passenger had 2 siblings on the ship and then their spouse was also on the ship, then that would have a SIB SP of 3, because the 2 plus the 1. And then for part, that's the number of parents plus children. So if you had 1 mother on board and then 1 son on board, you would add 1 plus 1 and you get 2. So 2 would be 2 under the parts column. So an important note here is that it doesn't include like other family relationships like uncles, aunts, nieces, cousins, so that information is not incorporated in the data. Next, we're going to take a look at the columns. So these columns are exactly what we expected. We can just search them. We can just get them to come out by doing traindf.columns. We can take a look at the heads. This is the first 5 rows of the data set. For this particular passenger, we can see that their passenger ID is 1. They did not survive, and as but guess they had a low, they were in the 3rd class, so they were in the bottom part of the socioeconomic status. And you can look at other information about the passenger. We can describe, so describe will take the numerical columns and then look at the distribution. So we can look at, for example, the average age. We can look at, the different standard deviation between the age, look at the count here. So a bunch of information about the numerical columns. We can pick out what describe. We can use info to help us see the data type, as well as if there was null columns. So it looks like all of these are, well, most of these columns are fine, except we have a few nulls in embark, we have a few in cabin, we have quite a bit, we have some also in age, right? So very quickly allows us to see, the null values, and those are important because if we don't address them, our model might perform poorly. So our numerical values, we can make some histograms. And we can see that the average age is again around 30. We can check the fare, so how much people paid on average. And then we can check the distribution. Parts, we can see there's 3 classes here, and then we can see the SIB SP column and whether they survived or didn't. As you can see here, it gives us a very quick snapshot that far more passengers passed away than the ones that actually survived. And we can quantify that by just running this, checking the value counts here. So 549 people passed away and 342 passengers survived. And it's good to have balanced data. It'd be ideal if these columns were exactly the same, but most data sets, that's not the case. But we have to work with what we have. So we're going to make a baseline model, and in this case, the baseline model is that all the passengers are going to be, we're going to predict the case that is the most common, and that most common case is that the passenger passes away. So if the passenger passes, so for every single passenger, we're essentially going to predict that they didn't make it. And if that's the case, then we'd be correct for 549 of the passengers. And that we can calculate the accuracy of that, which would be 549 divided by the sum of this. And that gives us about 61%. This is our baseline model, and our goal is to beat this building some machine learning models. So next, here's some quick remarks about the data. So passenger ID is a random number, right? We saw it means really nothing. There's no distribution here. It's just some random string of numbers given to the passengers. So we can probably drop that. We have the numerical columns, survived, passenger, class, etc. These ones are numbers, so we can use these to build our model. And then we have other ones that are the categorical variables, which are essentially, these are strings, right? These are text. So we would need to process these or somehow do groupings before we can actually use them in our model. Next, we're going to be dropping redundant data. So sometimes the data is already captured somewhere else, so we want to just drop that in because we don't need it. So passenger ID is something we call redundant because it's not useful and not helpful. We can quickly check the shape of our data. to see the number of rows in our training set, there's 891. In our test set, there's 418. And then we are going to go ahead and drop the passenger ID column from our training set. So that drops it, or just dropped it right here. We can quickly check for nulls. So for example, there are nulls in the age, as we saw, cabin and embark, and we saw some. And so this is our test set, our training set. In our test set, we also have some nulls in age, cabin, and embark. So it would be important to somehow address those nulls before we go too far, because those are going to be a problem in our prediction if we leave them there. That concludes part 2.